Okay, so now we're gonna go on to more complicated number sequences. It's very different from just now when we had simple sequences. We can easily derive that the general patterns like 2n, 3n, 8n, 5n. Now, the first step to finding a general term of other sequences is actually your first step is always to find the common difference. So in this case, from the first term to second term, there's an addition of 3. Here as well, an addition of 3. Now this is not so straightforward because you don't have a n value, right? You technically don't have an n value. So it is not as simple as just now 2n, 3n, so on and so forth. So in this case, the common difference here is plus 3. Okay, with that being said, let's start to look for a pattern. Okay, looking for a pattern is not easy. It takes a while. Okay, it's all about adding or subtracting numbers or even multiplying them if necessary. So the first step is the first term we have is equals to 2 and 2 is just equal to 2, nothing much, right? And to get the second term, it will be 2 plus 3. Okay, I'm going to take, is usually taking the first term and adding 3 to the first term. Right? Now what happens here is in the third term, you will take the second term and you will add a number of 3, right? So 2 plus 3 is the previous term and I add 3. Correct? Make sense? Can you all see that what I'm doing is just adding 3 to the previous. I do the same for the fourth term. Right? I add 3 to the previous term. Okay? I do the same for the fourth term. Okay, do you begin to see a certain pattern here? Okay, that you're actually consistently adding 3 and the 3's that you added previously remain. You see all these things here remain, right? Now we're going to do something about all these 3's. Okay, what remains constant? There is a 2 plus something, correct or not? The original term remains. Okay, so in this case, what I have is this is actually simply as 2 plus 3. Okay, I'll come to this later. Okay, but in this case, 3 plus 3 is equals to 6, right? But 6 can be written as 3 times 2, correct? Okay, can I write 3 plus 3 as 3 times 2? Okay, go and calculate them on a calculator. They are actually the same. Okay, the same for these. They must be equal, right? So I have 3 of the 3, so that will be 3 times 3. Okay, can you see that there is a very, 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 very unique pattern here? Okay, that is happening. Okay, this is actually quite tough. It's not that easy. Okay, so in this case, this is 2 plus 3 times 4 of them. Oh wow. Okay, so can you see there is what remains and what does not remain? Okay, the initial 2, which is over here. Okay, let me use a smaller one. Okay, the initial 2 remains, right? All these remains here, correct? What we are manipulating is that we are manipulating all these 3's. I am rewriting the addition of 3's into multiplication. Okay, you can do that. Okay, and actually the first one over here, can I write it as 3 times 1? Right, I could actually write that as that, right? Then what about the first one? The first one will be interesting. Okay, technically is 2 plus 0, right? But can I write it as 3 times 0? Hey, think about it. Okay, I need you all to start thinking about mathematics. Think about the mathematics here. 2 plus 3 times 0. Is it the same as just equals to 2? In fact, it is. Because 3 times 0 is 0. But right here, we see a pattern. Because I'm going to connect what you see here. Can you see this is an increasing number of order? And this is always smaller than the position number. Can you see now the position number here is 1. So if I have a column here for n, this will be 1, 2, 3, 4, 5, right? This is the position number. So can you see the position numbers are always 1 less than the position number? So I can say that in fact what I have here for the general nth term is 2 plus 3 plus 3 plus dot 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 plus 3. Okay, but there's a lot of 3's that I don't know, but in total, okay, in total here I'm adding n minus 1 3's. Okay, I'm adding n minus 1 3's, and is that just 2 plus 3 times n minus 1? Okay, what I need you to see is that this number here will always be 1 less than the position number. I say again, this number here will always be 1 less than the position number. Of course, you have to simplify it to make it 2 plus 3 times n minus 1. This is equals to 2 plus 3n minus 3, and this is equal to maybe I shouldn't write it here, I should write it at the bottom. Okay, so in this case here, this is 2 plus 3 times n minus 1 equals to 2 plus 3n minus 3, and this is equals to 3n minus 1. Okay, so the general term now is 3n minus 1. Okay, this method is a little bit hard, it's a little bit tough for you to understand. I need you to watch this video a few times, write down things that you may not understand. Okay, use a pencil. Okay, and then I can clarify it. Alright, so method 1 is to look for a pattern, which is quite tedious. Now method 2 is slightly different. Method 2 is all about transforming it to a relatively similar pattern, easy pattern. So in this case, if you realize, if I add 1 to this, it will be 3, right? I add 1 to this, it will be 6. I add 1 to this will be 9. Okay, I just add 1 to everything. So if you add 1 to one of them, you must add 1 to everything, such that the sequence stays the same lah. Okay, 3, 9, 12, 15. You realize that in this case, if I have this term here, I also must add 1 to find this. Okay, so in this case, this new sequence here, we know the general general term. The general term here is 3n, right? Because 3, 6, 9, 12, 15, they are all multiples of 3. The first term is derived by getting 3 times 1, 3 times 2, 3 times 3, 3 times 4, 3 times 5, so on and so forth. So what happened is that you need to add 1 to get 3n. But what about the reverse? Isn't it just 3n minus 1? 3n minus 1 plus 1 gives you 3n. So therefore, Tn is equals to 3n minus 1. Okay, this is method 2. Okay, and these two are the methods that the textbook has illustrated. I'm going to introduce you a third method. Okay, you may want to do this. So I'm going to use this side here. I'm going to write down. Okay, the first step is always to write down all the pattern, all the terms. Okay, so 5, 8, 11, 14. Now, of course, the second step, what is the common difference? Okay, so what combines them together? So in this case, this is plus 3, plus 3, plus 3, plus 3. Okay, now with this plus 3, I'm going to take the common difference, which is 3. I'm going to straight away multiply it to n. Okay, 3n plus a question mark. Okay, the term now is 3n plus question mark. Okay, why the question mark? The question mark is very important because we need to check whether is there anything it adds on to have the general term. Now I'm going to let n equals to 1. What does n equals to 1 mean? N equals to 1 means the first term, right? So t1 is equals to 3 times 1 plus this question mark over here. Okay, so what is term 1? We have the first term, which is 2. Okay, so 2 is equals to 3 plus the question mark. We can actually find the question mark now. So the question mark is equals to negative 1. So I can substitute this back, this question mark, into here. And hence, Tn is equals to 3n plus negative 1, which I can rewrite it as 3n minus 1. This is method 3. okay, when it comes to finding your general term. Actually, this is very similar to some of them here, but I'm just reversing this idea of general terms to actually find the general term. Okay, so please go ahead and review this video a few times if you need to, and I hope this gives you a better understanding of how to find general terms of more difficult examples. Alright, so that's all for this lesson.